second part is IC engine, internal combustion engine. So the refrigeration part will be taken care by Professor Saurabh Mitra, and I will take the part of IC engine part. And in 1 week, we have a 4-hour class. So 2 hours for IC engine class and another 2 hours for refrigeration class. So right now, Monday and Thursday, I will take the class for 1 hour, and on Tuesday, Professor Saurabh Mitra will take the class regarding the refrigeration part. So that has to be very clear that we have a 2 parts in this course, refrigeration and IC engine. Professor Saurabh Mitra will take refrigeration part on each Tuesday, and I will take the IC engine part on Monday and Thursday. Now, IC engine part and refrigerations both are such a kind of the device or appliance that you are using it from long back. So at least it doesn't require too much information or background. But when we will learn about little bit deeper inside that how things is working, what are the different parts, how we can improve, all these things we are going to learn in this chapter. So IC engine part or internal combustion engine part, that is my responsibility for this ATF 1. I'm hoping that all of you probably at least know how to drive two-wheeler, motorized two-wheeler. Some of you I may be expecting that you also know how to drive the four-wheeler. So let us, Aditya Agrawal, can you unmute yourself, please?
Yes, sir.
Yeah, Aditya, do you know in two-wheeler or four-wheeler how to drive?
Yes, sir.
Which one do you know?
I know only gearless bikes like Activa and all.
Okay, that's fine. So you have Activa?
Yes, sir.
Is it petrol engine or is it diesel engine?
So petrol engine.
How do you know?
So because during filling we ask for petrol.
Is there any other way? How do you know? Suppose you don't have flexibility to go to the petrol pump and fill up either petrol or diesel, then how do you know it is a diesel engine or it's a petrol engine?
So I'm not sure.
Yeah. So these are the things what is the best thing is that this is very live subject. All this either IC engine or refrigeration. This is live subject. I believe that this course can be taught in the laboratory itself. We don't need to go to the classroom and use the blackboard. In the laboratory, we can teach all sort of the things. So this is very live subject where we are using it, that what is called that technology, we are using it. So we know, so that is why I'm saying that it is a very live subject. And don't hesitate to ask the question, any sort of the things. Even if you ask some of the questions, I can learn little bit. So don't hesitate, ask the questions as much as you can. Okay, without any hesitation, without even thinking that whether it is a easy question or hard question, what my friends will not think, what I will think, don't worry about that. Just ask the question. Okay. Anyone who drive four-wheeler? It is a kind of, today I would like to know a little bit interactive kind of the session so that at least understands that where is the class lies, and from there I will try to take forward. So anyone who drives four-wheeler?
Yes, sir.
Yeah,
Yes.
that's a really good. Yeah. Okay. So which car do you have at your home?
Hyundai i10.
Hyundai. So it is a petrol engine or it's a diesel engine?
It's a diesel engine.
Okay. So now how do you know it's a diesel engine?
Same case
Same
spelling.
case as Aditya, yeah. So now see, you guys are engineer, yeah? And you are utilizing that a part. So engineering part you must also know about it. Okay. Who else? Anyone, please come. Yeah.
Yes,
Ankit.
I know.
Uh, who is speaking?
Hello, sir. It's Game Tarik Vijayakumar.
Yes, 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 yeah. So Vijay,
So my
what
name is
kind of
Alex.
vehicle do you have?
So it's a Honda City.
Honda City. That's really very good. So it is a petrol or diesel?
So it's a petrol engine.
So same question for you also, Vijay. How do you know it's a petrol engine or
So it
gasoline
was
engine?
written in the manual and
Okay,
and
at least okay, that's really very good. That at least it is written in the manual. Mhm. Apart from filling gasoline in your car, yeah. Okay. Do you drive, Vijay, for this Honda City?
yes, sir.
Yeah. So there's one more question, Vijay. Can you explain to the whole class that when you press the accelerator,
Yes, sir.
why the speed of the engine in our vehicle increases?
So the whole procedure.
No,
So sir, I don't.
just whatever you have in your mind.
So when we, I mean, when we accelerate I mean, the fuel starts to burn more. I mean, the fuel consumption increases, and thereby it increases the, I mean, the working of the engine, and it will increases the RPM of the wheels, and thereby it increases the speed.
Mhm. That's fine. So as Vijay is saying that when he pressed the accelerator, the mainly he's saying that the more fuel will go inside the engine, fuel consumptions or it will increase, and therefore the RPM of the engine will be increased. That's fine. But there are a lot of things happens between this pressing the accelerator and more fuel. There are a lot of things is happens. Anybody in the class, okay, please come forward and explain the whole class that why the speed of the vehicle or two-wheeler increases when you increase the accelerator. This is the very common questions that almost everyone have a such kind of experience. What happens? What happens when you press the accelerator? What are the things is happening inside the your engine or any sort of the things, and because of that the output is coming in terms of the increase in the RPM.
So when we push the accelerator, more fuel comes to the engine, um, and hence making it burn hotter, and then the system speeds up.
Why, Subham, more fuel will come?
So
Sir,
maybe due
because the
to
piston
the opening.
strokes the fuel.
Just hold on. Just hold on. Subham is trying to explain. Yes, Subham, go ahead, please.
So maybe when we push the accelerator, there will be more opening for the fuel to come. Maybe I'm
Hmm.
not sure about it.
Okay, that's fine. That's fine. No, even I'm not sure too much things. Okay, so that's why we need to learn from each other. Yeah, another student who was saying.
Sir, I was
Sir,
thinking,
Mm, okay, at least
sir, I
one
was
more.
thinking it's like dustbin which opens on pressing the like pressing with leg. The dustbin upper lid opens up. It's kind of like that system, so that fuel input increases.
See, the thing is, fuel is obviously is going to be increased, no doubt about it, because fuel is nothing is but in terms of the energy. If you are not giving the energy, you are not going to get more output, and here output is in terms of the speed. But the question is why the more fuel is going to be increased. So as Subham is saying, that might be when I'm pressing the accelerator, it is connected with some kind of the way that it is fuel is going to be increased. Okay, in if Subham's statement is very much uh, correct, if we will talk about a diesel engine, but once we will come back to the gasoline engine, okay, or petrol engine, then that statement is not going to be correct. So that here, therefore, I am saying that when you press the accelerator, um, yeah, apart from Aditya, anyone who knows the two-wheeler?
Sir,
Yeah, Rishabh. Yeah, Rishabh, which two-wheeler you drive?
bike,
Bike, which bike?
CD Deluxe,
CD Deluxe. It is a petrol or diesel?
petrol.
Petrol, that's fine. So when you press the accelerator or when you rotate the accelerator, you think, have you seen there is a wire is coming out from that part? There's
Yes, sir.
metallic wire. Yeah. Where is the other end that metallic wire goes? Have you tried to see it? Have you tried to trace it? Where it is goes? One end is connected to the accelerator, yeah?
No, sir.
No. Why? No, I'm asking one end of the wire is
I mean, I
connected
have
to the
not seen
accelerator.
where the other end goes.
Okay, that's fine. So that's okay. Anyone else? Two-wheeler group? Jatin Saini?
Yes, sir.
Yeah, Jatin, do you drive two-wheeler?
Yes, sir.
Which which two-wheeler?
So both gearless and geared.
Any Activa and some bike also, yeah?
Yeah.
Okay. So for you case also, have you tried to see that where is the other end of the accelerator wire goes?
No, sir.
Sir, it goes to a switch.
Mm-hmm.
It goes to a switch, kind of switch, which when pressed, the fuel will inject more in that.
No. No. It's not going to be any relay or any switch that will switch on or off or increase the fuel.
Means that the accelerator wire is connected somewhere, and means actually it happened so that my friend's accelerator wire got damaged. So he pressed some. There is some kind of switch near the fins of that engine.
So
So
spark.
when that means when
Uh-huh.
that switch is pressed, then it goes.
No,
It accelerates.
are you talking, Kritis, it is a bike or you're talking about four-wheeler?
I'm talking about bike.
Bike. And you are saying in the bike, one of the bike of your friend has got damaged and he changed the
Accelerator.
accelerator wire and he probably give you the information that it is another end is connected to the switch, yeah?
He was pressing something, and when he pressed something near the pins, then the bike was accelerating forward.
Okay, no, it's not. I will try to explain later on. Okay, please, other who was saying something?
So it goes at the other end, goes to the spark plug ignition.
Okay, so Vishal, what it will do with the spark plug?
So it will electricity will be conducted, and there will be the cylinder piston will open the valves basically.
Okay, that's really very good. Okay, that's good. So these are the questions we must know that why it is happening like that. Yeah, Kritish, do you drive two-wheeler also, no?
I don't have a bike, but I just have Activa. I'm my friend. I have gone through with
Yeah.
friends with on bike.
Okay, Jatin.
Yes, sir.
Yeah, Jatin. In Activa, when you press the start button, yeah,
Uh,
why your engine gets started?
I guess there's something called spark plug or something which gives the initial spark and makes the engine start.
These are the small questions. Okay, when you drive the two-wheeler from today onwards, what my aim is that at the end of this semester or at end of this course, whenever you drive two-wheeler or four-wheeler, you feel the sound of the engine. You should know that if I am doing something, then in what way my engine is going to respond back. Such kind of the feeling. If I am able to um, uh, to notice you that you can feel such kind of the things whenever you drive two-wheeler or four-wheeler, I think my objective is accomplished. That is what my aim at towards the end of this course. Next onwards, whenever you drive two-wheeler, four-wheeler, you think about it. See, the things is how easy questions all these things that whenever I press the accelerator button, either in the two-wheeler, those who have a starter, self-starter, or in the four-wheeler, whenever you crank the engine, whenever you rotate the your key, why the engine starts, what is happening, what kind of the things is happening there. If I am pressing the accelerator, why the speed of the engine is increasing, how the air and the fuel is going to be regulated. These are the such a small things that when you drive the two-wheeler or four-wheeler, you must ask by yourself. And that is really what kind of the technology is there. I hope that some of you are very fond with F1 series kind of the competitions, or I don't know whether some of you are maybe the part of the team kart of our campus or any electric vehicles. So these are the things you must ask by yourself that why it is happening, because you are not the person is a kind of normal person, so that you are only interested to learn that how to utilize the any equipments. Your job is to know that how the equipment works and how I can improve further. That is the difference between you and a normal person. So that kind of the questions you must ask, and that is what we are going to learn. Obviously, there are so many questions. There is big subject. Okay, in half of the course, there is ATF1 is a full course, but in half IC engine or refrigeration is going to be divided half. It's a bit difficult for me or either Professor Saurabh to cover so many things of the IC engine part or refrigeration part, but we will try to give the flavor of the each parts so that in the future whenever it requires you can take it forward. So that is what we are going to learn in this subject. Okay. Obviously, whatever the questions I have asked right now for all of you, think about that, because if I will give the answer right now, I have to use so many technical terms. And if that technical terms is not clear or you cannot visualize it in your mind, or then it's really very difficult to understand the question or answer. So keep it in mind. I'm holding the answer of these questions. In coming 3-4 classes, everything is going to be clear. So what we are, as far the academic purpose is concerned, what are the things we are planning to learn in this subject? Let me explain the syllabus. So yeah, it is a applied thermofluids. It has a 4-hour contact, and we need a prerequisite of the heat transfer and the thermodynamics. That is more it's really very required for the refrigeration part. As far as the IC engine part is concerned, it's not as much as required as in the refrigeration part. So you need to little bit refresh of your thermodynamics particularly. This part in the refrigeration part you are going to learn, it is going to be described by Professor Saurabh Mitra tomorrow. What we are going to learn in the IC engine or internal combustion engine. So initially, first of all, we will start with the introduction that contains the first of all we have to learn what are the different components of the engine. Now see, the things is sometimes I'm using the term vehicle or bike, or sometimes I will use the term engine. Engine is the subset of the vehicle, is the part of the vehicle. So our main objective in this course is to focus on the engine. In the vehicle, there are so many things. The engine, transmission, electronics part, control part, dynamics part, vibration. There are so many things. When we are going to consider the overall the vehicle part. But in this course, obviously, we are not going to cover all the parts. We are very narrowing down our objective, and our objective is to mainly focus on the engine part. So first of all, we have to learn that what are the different components of the engine. Not only we have to know what are the different components of the engine, but what is its geometry, okay, how it looks like. That has to be very clear. Because if I am saying piston, connecting rod, crankshaft, valve, engine head, block, liner, what is all these things? Unless the components and the shape of the component, geometry of the component, it is not clear in your head, then it's really very difficult to understand. But once it is clear, then we are going to understand each other very fast and without any confusion. So first of all, we will clear the part that what is the different parts of the engine. What are the naming part, or in general it is used in the IC engine books or in general technical language. So we will understand the nomenclature of the parts. How many cylinders in the engine, single cylinder, double cylinder, 4-cylinder, 6 cylinders, what kind of the cooling systems normally is available. So that is what. After that, we'll understand about the 2-stroke and 4-stroke engine. Obviously, 2-stroke engine nowadays is not in used. All of the IC engines, particularly right now, whatever we are utilizing right now, two-wheeler, either in the bus or 4-wheeler or two-wheeler, all are the 4-stroke engine. So what is the 4-stroke engine? What is the SI? It means a spark ignition, and CI, it means compression ignition engine. What does it mean? Right now I'm using the term, even we started the discussion with whether it is a gasoline engine or a diesel engine. Gasoline engine, petrol engine, or a spark ignition engine, all has the same things. Diesel engine or compression ignition engine, that is the same nomenclature, meaning the same. So right now, without any introduction, we just use the word that is it a gasoline engine or is a diesel engine. Even though I have not stated to all of you that what is the difference between the SI engine, that is a spark ignition engine, and CI, that is compressed ignition engine. SI engine, that is a spark ignition engine, we also call it gasoline engine. Compression ignition engine, we also call it diesel engine. So what is the difference between that? Okay, it is not just that since we fill the gasoline, so therefore it is a gasoline engine, or fill with the diesel is a diesel engine. Yes, that is one of the way to differentiate between the SI and CI, but there is a lot more that we need to understand between the CI and the SI engine. Obviously, some of the things you may have learned in the thermodynamics, okay, but I will come on that. We'll understand some of the terminology that how the there must be some kind of how we can say that suppose we have a two engine, then which engine is really very good in terms of what? There must be some kind of the parameters. Based on that, we can evaluate the given set of the engines, and then we can say, yes, this is really very good compared to the other engines. So what are these parameters? Okay, obviously there are so many parameters, but we will try to learn that what is the thermal and mechanical efficiency, combustion efficiency, volumetric efficiency, what is compression ratio, torque or load, how much power, what kind of the power, it is a brake power or indicated power, what is mean effective pressure. There are two kind of the mean effective pressure, brake mean effective pressure, indicated mean effective pressure, what is the fuel consumption, what is the air fuel ratio. These are the parameters we are going to understand. Then the spark ignition engine or diesel engine works on a different thermodynamic cycles that we'll try to learn. I'm hoping that in the thermodynamics you have gone through at least the Otto cycle and diesel cycle. Whether my assumption is correct? In your thermodynamics, have you learned about diesel cycle and the Otto cycle?
Yes, sir.
Okay. And can you explain me, if you can recall, that what are the things you have learned about the Otto cycle and diesel cycle apart from the thermodynamic process? Have you tried to learn about what is the thermal efficiency, how to calculate the thermal efficiency? What is the work done? All these things have you guys already covered in the thermodynamics, particularly this part? Please tell me, so that based on that I will think that whether I should, how much I have to cover on part 4. Anyway, I will revise it. Okay, I will revise, but I will try to revise in little bit faster way about the Otto cycle and the diesel cycles. Now there is a valve. You know that the air goes inside the engine, there is a combustion takes place, and then exhaust comes out. In the layman language, I'm just trying to say how the air goes inside the engine, how the exhaust valve goes out. Okay, what is the valves? What is the valve? What is the diagram? When valve is going to be open, when it is going to be closed, what are the different kind of the valves, that we are going to learn it. And the most important thing is that it's not, I should say most important things, is very important, that how, where the fuel and air mix with each other. What are the different technology right now we have in the market through which the fuel is injected and it get mixed with the air, and then it is ready for the combustion. So there are different technology. There are very advanced technology, the common technology, that some of the technology that is right now it is not being used, but obviously that is the fundamental kind of the technology. So this technology, what is all this technology that we are going to learn? What is the port fuel injection system, gasoline direct injection system, common rail direct injection system that is mainly used for the diesel engine. What kind of the ignition systems we have? Conventional ignition system, electronic based ignition system. So after, if we will cover up to the 7, then by the end of the 7 parts, we know that how the air fuel mixing takes place, what are the different technologies, and then up to here your fuel and air is ready to burn. Then we'll come to the combustion part, that how the combustion takes place. Okay, so how the combustion in the SI engine takes place, how the combustion in the compressed ignition takes place. how the pressure inside the combustion chamber we can measure it. You know probably the fluid dynamics, or I don't. Hopefully you have done some experiments also, that how the pressure measure. But is it the same way that we can measure the pressure inside the combustion chamber in the IC engine also? Or it has some advanced technology that we need to take care, because it is a very dynamic conditions where the pressure varies very fast. So in that dynamic conditions, how we can measure the pressure, that we can also will try to learn. After that the combustion takes place, you all of you know that your IC engine, one of the demerit is the exhaust emission. The I hope it is general knowledge, you all of you are aware that the emissions that is coming out from the engine is harmful for your health, or for the health of all of us, and it is also harmful for the environment. And therefore we have a several emission standards. Anyone who have a car at their home, please try to find it out what kind of the emission standards follow your cars. Right now, what are the what is the standards, Indian standards we have. So then after that, there are so many things is going on. Okay, please unmute yourself. There is a around the corner stories goes on that we have a limited gasoline and the diesels. That is true. Please check your, some of you is unmuted. Pulkit, can you unmute yourself, please? What happened? Yeah. So yeah, I was trying to say that we have a very limited we have a limited fuels, gasoline, diesel, all these things. So what are the alternative fuels? Apart from the diesel and the gasoline, what kind of the fuels we have, or we can use it in the IC engine? Okay. Now you also know that there is a intense debate is going on about the competition between the IC engine and the electric vehicles. There are two groups right now, that one is trying to explain that electric vehicles is the everything and it can solve the problems of the emission of the fuel or whatever. The conventional your IC engine, it is still is one of the prime technology for to provide the transportation, and it has been used from the long times. Several people is question mark as asking the questions that whether the IC engine is going to be survive. Okay, there's intense debate is going on. We are not going to be in such kind of the debates. Okay, but we, after all these things, we will be in the positions to find out the answer of last part, that which way we should go ahead and how we should go ahead. But to enter in such kind of the debate, we must know about that what is the gas engine or what is the electric vehicles and what are the other things. There are a lot of, apart from the technical parts, there's a lot of policy makings is also involved in deciding all sort of the things. So this is the what our intention is to learn in that part. Okay, we'll try our best to cover almost all the parts, but it all depends that how we both going simultaneously, depending upon how fast you are absorbing and how accordingly how fast I am going. So these are the things we are going to learn in this section. There are so many things also that you can put, sir. If you can cover this part also in this course, it will be beneficial for your knowledge, that I will try to accommodate. But at least what I would like in this class, and I will try to give you the just your assignments, not the assignments that you need to submit it. Only thing is that please, whatever the, if you have a car or two-wheelers, please go on the website of that cars or two-wheeler and try to find out the technical specification of that car or that bike. Those who don't have at the home, it's not a problem. If please just go, you have a flexibility, you can just go to the website of Maruti, Honda, Hyundai, Mahindra, pick any model and then find out the what are the technical specifications. And then next class when you come, then you have a set of questions that what is the meaning of the technical specifications. When I was going through that, then these are terminologies used. What are these all these things? So all of you, please at least find it out the technical specifications of one of the car or bike. It would be really very nice or more informative if you can find it out that in technical informations of your bike or your car if you have at your home. And the next class we will discuss on that particular specifications. Next time also those who is at the home now, okay, and also they have a car or two-wheeler, whenever you now drive it, try to listen the sounds of the engine. Think about that, what you are doing and in what ways your engine or your bike or your vehicle is responding back to you. So yeah, so that is the all the things we are going to learn. Okay. Yeah, a little bit. So next class onwards, what we are going to do, we will first start with the different components of the engine. What are the nomenclatures? Okay, these are the things we are going to learn. If I think all of you have a ATF lab also in this semester. Am I correct? ATF lab, Applied Thermofluids Lab 1.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, that's really very good. That is going to be a start from next week. So it's really very good for me. It will be helpful that to correlate whatever we are studying here, and then in the lab we are going to correlate it. Obviously in the lab you cannot do right now, that's fine, but we'll try to correlate. So that's really very good. Okay. Okay, let us have some just discussion. Krishna Kant, can you unmute yourself? Krishna Kant Rawat. Yeah, this is the demerit of the online class. You call the someone, he or she will not respond. Okay, no problem. Jives.
Yes, sir.
Yeah. Jives, can you tell us the different components, just whatever you know the components of the engine? Name of the component.
Sir, the piston and
Piston, okay. Anything else?
sir, the engine block, the cylinder head.
Cylinder head, okay. Piston, cylinder head. Anything you would like to add?
No, sir.
Okay, Manjit. Manjit, are you there? Those who are not responding, at least you guys inform him that is not good. Next onwards, I will note it down. Nikhil, are you there?
Yes, sir.
Yeah, Nikhil, can you add some of the components of the engine? Piston, cylinder head, one of your friend has already told.
Sir, is would spark plug be called a part of the engine?
Yes, sure, why not?
Because it's actually outside and the engine is a cylinder type of thing.
No, whatever the engine part, whether it is accessories that is plugged in it, everything we will consider as a parts of the engine. So a spark plug, that's really very good. Yes. Anything else?
I can't remember anything. There's a cylinder and there are pistons.
Cylinder liners, cylinder head, a spark plug. These are some of the things I believe it is a general knowledge questions. You don't need to
there is an outlet for the smoke to go out.
Yes, that's really very good. At least, do you know the technical word?
Silencer.
It is called exhaust manifold.
Okay.
Okay.
Yes,
exhaust manifold through which the exhaust is going out from the engine to the atmosphere.
Yes.
Okay, that's really very good. Good, very good. Ayan?
Yes, sir.
Can you add something more?
The crankshaft.
Crankshaft, very good.
So like I think like that's all I knew, and the rest were covered.
Okay. Ayan, can you tell me whenever the combustion takes place in the engine, have you think about that? What is the maximum pressure inside the combustion chamber? Whenever the combustion takes place, approximately what is the pressure inside the combustion chamber going to be? Any guess based on the just general knowledge?
So 10 atmospheric pressure.
Okay, that's fine.
Yes.
Okay. Anyone else can guess approximately how much is the pressure? Whenever combustion takes place either in the diesel engine or in the spark ignition engine, how much is the approximate pressure?
So maybe around 20 to 30 bar.
Maybe, okay, 20 to 30 bar. Somebody else?
Sir, 100.
100 bar, okay, very good. Obviously, it depends upon the so many factors, okay. Whether the engine is running at idling condition, okay. One is saying 100 to 150 bar, okay, that's fine. It all depends upon the kind of the engine, whether the engine is running at idling condition, is just the engine has been started or the full speed or whatever, okay. So yes, so it all depends on the several things. So I'm talking about the diesel engine, okay. There's a reason why I'm taking the example of the diesel engine, because it is much easier right now at this point. So in the diesel engine, particularly for the passenger car, the pressure may vary from 40 bar to around 100 bar, okay, for the passenger cars. 100 is when it's much more. So that is the kind of the pressure. You know that what is the meaning of 2 bar or even 3 bar pressure? In your cycle, can you tell me what is the pressure in your tire? In your cycle, what is the tire pressure, filling pressure? Come on, come someone forward and tell me the pressure in the tire.
Sir, something around like 60-70 psi.
60 psi, it means approximately 4 bar.
In two-wheeler, it's 35 psi for rear, and for front, it's 32.
Yes, that's fine. So it is around, in your cycle, it is also around 2 to 2.5 bar. Now think about that 2 to 3 or 2 to 4 bar from the cycle to your car is enough to make it float. Here we are talking about 40 bar to 100 bar. That is going to be created during the combustion. For such kind of the pressure, and you know that there is a piston. I'm hoping that you have a little bit videos, you know the videos. How this sealing, how the pressure is not able to leak from anywhere. In the engine parts, when I was talking about the engine parts, some of you tell me that there is a piston, cylinder head. Between that, whatever the space, it is called combustion chamber. And there the pressure is going to be around 40 bar to 100 bar. Think about that. The piston is the dynamic, it is not the fixed, it is moving up and down continuously. How we are making the mechanical sealing? That the pressure is not leaked. If the pressure is leaked, then we are going to lose the useful work.
Through valve.
That we need to understand whether it is a valve or something else. Valve is the function is to just it will let it will allow you to it will allow for gas exchange process between the engine and the atmosphere. That is the function of the valve. I will explain it later on.
I think there are rubber rings, sir.
Rubber rings. Now ask yourself, how much is the temperature? Whether the rubber is going to be there, it is going to be work.
Sir, I am not sure, but like it could be like there is some insulating fluid that like it seals also, and it can like withstand the temperature without boiling.
Right now, I'm not expecting a correct answer, and neither I'm saying you are a right or you are a wrong. What I'm trying to say right now, just raising the questions in your mind, you are giving some of the answer. That's really very good. We need to find it out that whether it is a correct answer or if not, then what should be. So that we need to think about that how the pressure, such a high pressure, where we are talking about 40 to 100 bar, okay, or less than 100 bar, how the mechanical sealing be there, even slight leakage. There will be little bit pressure when we will go in much deeper into the components and the combustion, but it is going to lose the power, its full power. So which components of the engine is going to act as the sealing at such a high pressure and temperature? Therefore, I'm saying it is a very dynamic and harsh conditions of the pressure and the temperature. Everything is such a very complicated kind of the things, and it is going to be really very interesting. It is only thing is that stop me anywhere, anytime, clear your doubt. Don't let me go ahead. I would not mind even if I will cover the 50% of the syllabus, but whatever the 50% syllabus will cover it. If it is going to be clear to the 90% the students, I will be very happy. So ask the questions. That is the it is a theoretical subject. There is a slightly numericals also. There is a, but it is a mainly theory. But the theory is nothing like that. We need to remember it, or we need to do the ratta kind of the things. It's absolutely nothing. The theory is a kind of things that we need to understand, and that the that theory, we are using that part every day in our life. So yeah, so that is the whole part and the story of that part that we are going to learn in this course. Okay, I'm hoping that it is going to be very interesting, and but it all depends upon you, that how much you are asking the questions. As much you ask the questions, this course is going to be interesting. As long as I am going to only speak in the class, this course is going to be boring. Okay, so it all depends between us. Obviously, I am bound to speak in this class, whether you are going to speak or not. But if you want to make it interesting, then you have to also speak. So that is what the things we are going to learn. Okay, next class onwards, we will start our syllabus with this theory. Whatever we have raised the questions, it is going to be answered in coming 3-4 classes. Okay. Yeah, that's all from my side for today. If you have any questions, you may ask.
Sir, do you have any recommendations for the book which we are going to follow?
Yes. I'm sorry, I could not show you. Yeah. So see, the things is, these are the 4 books. But what I would say, this is internal combustion engine, that is written by Professor Ganeshan. He's a professor of IIT Chennai. It is very good book and very fundamental books. Okay. Then there is another book, Internal Combustion Engine, written by Professor J.B. Hagwood, John B. Hagwood. This book is considered as the Bible, Gita, whatever you can say, of the IC engine. But it is slightly higher. It's not slightly higher. Its standard is it's up one level ahead than any other books. But everything from A to Z in this book you can get it. So I would say these 2 books, all of you, this book J.B. Hagwood, I think it can be downloaded from our library. I don't know exactly. Those who are in the campus, they can also get it through the laboratory, through the library. And I think soft copy is also available. So all of you try to see whether you can legally download it, the J.B. Hagwood book. And the V Ganeshan book, I hope it should be. But if you have a J.B. Hagwood book, okay, and with my lectures and slides and the lecture, it is going to be interesting. So even if you don't have the big Ganeshan book, there's no problem. So at least my expectation is that everyone must have this J.B. Hagwood book. It's a really very good book. And then these 2 books, Gasoline Engine Management and Diesel Engine Management, that is written by Robert Bosch. Okay, this book is a kind of the story book, where what are the current technology is right now in the area of the IC engine or in the vehicle. Okay, it's really very interesting book. There is no numericals, no any equation. It's only some photograph and the descriptions, some sensor kind of the things. It's really very good book. So these books can be also downloaded from our library website. So try to download it 3 books. That's one is J.B. Hagwood book, Robert Bosch, Gasoline Engine Management and Diesel Engine Management. And with my lecture and the slides, I think we are going to, it's okay, there's no problem. So these are the book, I would say references or books that I would recommend. Please download it. Anyway, I'm going to upload this a slide, this book for all of you, so that you know that what are the syllabus we are going to cover and what are the books that we need to be following. Yeah, any other question? No, so okay, then see you on the next class, that is on Thursday. Tomorrow there will be ATF class, but it will be taken by Professor Saurav. He will describe the refrigeration part. Okay, so thank you. Let us close the session now. Bye bye.